let us understand about symmetric and skew symmetric matrices. If A is a square matrix, then we say that A is a symmetric matrix if A is equal to A transpose. If A is a square matrix and if A is equal to A transpose, then A is called a symmetric matrix. What is skew symmetric? If I consider a matrix B, which is a square matrix, and if B is equal to minus B dash or B dash is equal to minus B, then B is called a skew symmetric matrix. So, if A is equal to A dash, then A is called a symmetric matrix. And as I told you, if A is equal to A dash, it can happen only if it is a square matrix. Similarly, if you consider a square matrix and if it happens to be B dash being equal to minus B, then B is called a skew symmetric matrices. There are two theorems related to it. Let us discuss them now. Theorem number 1. For any square matrix A, with real number as entries, A plus A dash is always a symmetric matrix, is the first theorem. For any square matrix A with real number as entries, A plus A dash is always a symmetric matrix. And the second theorem goes this way. For any square matrix A minus A dash is always skew symmetric. Now, is there any relationship between them? Yes, it does exist. So, any square matrix A can be expressed as a sum of symmetric and skew symmetric matrices. So, for any square matrix A, we can write A as half of A plus A dash plus half of A minus A dash. So, this part, that is the first term, is a symmetric part, and the other term, which is A minus A dash, is a skew symmetric part. So, we have expressed A as sum of symmetric and skew symmetric matrices. So, if A is a square matrix, then A is equal to half of A plus A dash plus half of A minus A dash. Now, let us understand these concepts of symmetric and skew symmetric matrices using few examples.